there were a lot of videos to watch, and I don't really know if you all had time to watch all of it. So I want to talk about some of the ideas. Okay. And I want to draw a picture to try to set the stage for us. So let me draw a little graph here. Here's a set of axes. This. Okay. And let's say you have, 2 points, like let's say your domain goes from A to B. So we're going to graph everything within this interval. And let's say that my graph looks like this. Starts here, it comes up, comes down. It sort of goes like this. So this is my graph. This is y is equal to f of x. Okay. The first thing I want to talk about is I want to talk about the idea of a critical point or a critical value. So you'll hear me call it a critical value or a critical point, and it's the same thing. And if you had watched the video, how do you know when you have a critical value? Does anyone want to type the answer in the chat box? How do you know when this occurs? No answer? All right. It occurs in 2 situations. The first, that's right. Yes, Luciano, thank you. The derivative evaluated at your point, let's call the critical point C. The derivative is equal to 0, or the derivative does not exist. Okay. Now, everyone remembers the derivative equal to 0 part. Sometimes people forget the derivative does not exist part. So I drew this little picture to help you see this scenario. When I look at this, I see a variety of critical values. First of all, the derivative being equal to 0 means the tangent line is horizontal. So when I look at this guy, I can see, oh, here I have a horizontal tangent line like this. And here, I also have a horizontal tangent line like this. So if I were to call those guys C1 and I call this guy C2, those are both critical values. Okay. Now we also want to check where the derivative doesn't exist. And there's really 3 ways the derivative cannot exist, right? It could be discontinuous. You could have a corner or a cusp, or it could have a vertical tangent line. Those are the 3 ways that a derivative doesn't exist. So in this particular case, I tried to draw a couple of points where you have a little corner. So if you look at this point right here, this derivative doesn't exist. That would be a critical point, C3. And I try to draw one more there. That guy would be C4. So each of those guys has a corner. So if we kind of zoom in over here, it's like if you looked, the slope, if you come from the left, that's like a positive number, right? Maybe if you come from the left, that looks like +5. I don't know, I just made it up. But if you come from the right, this is a negative slope. Maybe that's like a -4 slope. So if you come from either direction, you don't get the same number. You come from the left, you get one number, a positive number. You come from the right, you get a negative number. Those 2 answers aren't the same. So the derivative does not exist here. So at this point, f prime of C3 does not exist. Right there. Same thing at C4. F prime of C4 does not exist. Again, it's a corner, it's a cusp. Is there any questions about that? No questions. Okay. So if we took a look at the worksheet, our first worksheet over here. You know what, I'm not ready to talk about this yet. I just started talking about the critical values, which is right here. Let me talk a little bit about absolute maxes and absolute minimums first. So if you look at this picture, there are, we can say that our domain is going to be this closed interval AB. And the absolute max is the largest Y value Y value in the domain. So it's literally the largest. So let's play a game. Let me ask you a question. I want you to go into the chat box. I want you to tell me where does the absolute maximum occur on this graph? So type your answer in the chat box where, the maximum, absolute maximum occurs at X equal to, type that in. And then we'll count it down. Ready? 3. Whoa. I don't know. Stop. No one wants to play this game. Ready? 3, 2, 1, enter. Good, good, good. I see a lot of the correct answer, which makes me happy. Really happy. So, to be honest, in my first class, the class I teach Monday, Wednesday, Friday, more of them got fooled than you guys did. So the correct answer over here is that the absolute max occurs at B, because this Y value is the highest on the whole domain. So in this particular case, absolute max occurs is at X equal to B. Now you might say, what about C1 right here? So this point right here, C1, this is a maximum, but it's not bigger than this guy or really any of these guys over here. So this is not the absolute maximum. So this guy is the biggest in the neighborhood containing C1. So I'm going to say we have a local maximum at C1. And the analogy is, who's the best basketball player in the entire world? I guess that's very debatable. I'm going to just say LeBron James because we live in LA. So let's say the absolute maximum, the best basketball player in the whole world is LeBron James right here. Okay. Well, who's the best basketball player in our class? I don't know who that is. Does anyone want to volunteer their name? Let's say it's Selena. So if Selena is the best basketball player in our class, she would be like the local maximum. Like, yeah, she's better than all the rest of us in the class, but she's not the best basketball player in the world. That would be LeBron James. Does that make sense? So a local maximum is like you're the best in your area, but being the best in the whole domain, that would be the absolute. Okay. So same thing with absolute minimums. In this case, if you looked at the absolute minimum, you would be saying, what's the smallest Y value? And in this case, that occurs at C2, right? Because this point is lower than everywhere else. So maybe I should say we have an absolute min at X equal to C2. So these are just different examples I have, just to make it clear. We have a local maximum at C3, right? And then we have a local minimum at C4. Does that make sense to everybody? Any questions? All right, cool. So, you know, when you have the time, if you didn't already, you should really kind of watch these videos, I guess.